Welcome back to my channel, W Dara in the Mathematical Cockpit. Now, today we are answering a question on curve sketching. We are answering a question on functions. We are given a cubic function there, fx is equal to minus x to the power of 3 minus x squared plus x plus 10. We are required to write down the coordinates of the y-intercept of f. At the y-intercept, x is 0. So wherever there's x, we put a 0 to find the y-intercept. So in this case, we are going to say the coordinates are 0. So if you put a 0 in x there, you get 10. So this is the y-intercept. Now, we are on B now. We need to show that 2 is the only x-intercept of f. So here you use a vector theorem. You say f2 is equal to minus 2 to the power of 3 minus 2 squared plus 2 plus 10. What you get here is minus 8 minus 4 plus 2 plus 10. What you get a 0 there for that one. So x minus 2 is a vector of this. X minus 2 is a vector of fx. Now, can we just write fx nicely so that we get rid of all the negatives and stuff? I can say now fx is equal to, I can take out a negative there to make it look nice and beautiful. So I'll be having x to the power of 3 plus x squared minus x minus 10. Now what I need to do now is I need to factorize this part here so that I find all the solutions of x. For the meantime, I can ignore the negative sign. I will now use long division. I'll provide a link in this video in the comment section, or that refers you back to a video where I was talking about long division. Some people use synthetic division, but I'm used to long division. But in the next upcoming videos, I'll also try and teach you this synthetic division. Okay, so now my long division method. I will put x minus 2 there, dividing x to the power of 3 plus x squared minus x minus 10. X into x to the power of 3, x squared. I multiply this and that, x to the power of 3 minus 2x squared. Now I change the signs. Wherever there's a negative, I put a positive. Wherever there's a positive, I put a negative. So x to the power of 3 minus this one, get a 0. I don't need to write that. Then this plus this, I get 3x squared. Next, I divide x in there, I get a plus 3. 3 times x, I get 3x squared. Then 3 times minus 2, I get, that's a 3x here, I'm sorry. Then 3x times x, 3x squared, okay, like that. Then 3x times minus 2 is minus 6x. Likewise, I put a positive there. Wherever there's a negative, and I put a negative wherever there's a positive. So I'm adding this up, they give me a 0. I don't need to write that down. Then I'll add these ones, 6x minus x. I get 5x. Okay, so now I'll divide x in there, I get a plus 5. I multiply again there, I get 5x, and there I get a minus 10. Then I change the signs, positive here, negative there, get a 0 here, and I get a 0 there. So there's no remainder. So let me rewrite this thing again. I'll say now fx is equal to, remember I have to put that negative sign, I have to take it back, is equal to minus x minus 2 multiplied by this one, because I've divided this one by this to get that. So I'll be having x squared plus 3x plus 5. So I'm looking for the x-intercepts of this function. So y is 0 there at the x-intercepts. So I'm saying this is equal to 0. Then I'm saying minus x minus 2, x squared plus 3x plus 5 is equal to 0. Then I divide by the negative both sides. I'll still remain with x minus 2, x squared plus 3x plus 15, that being equal to 0. Now, I can now try to factorize this one, or maybe to solve this one, because I'm saying x is equal to 2 for this one. Now, for that one, it has to be equal to 0. So I'm saying x squared plus 3x plus 5 is equal to 0. Now, I need to solve that. I can use the quadratic formula there. It says x is equal to minus b plus or minus the root of b squared minus 4ac over 2a. Now let's substitute those values of that expression, of that equation in there. So I'll say x is equal to minus 3 plus or minus the root of b squared. B squared is a 9, 3 squared minus 4 by a 1 there for a, and a 5 there over 2a. So I'll be having x is equal to minus 3 plus or minus root of 9 minus, that is actually a 20. So I get minus 11 here over 2 by 1, that is an a, okay? So there are no real roots here. There are no real roots here, because the square root of minus 11 is at this level, it's undefined. So we conclude that 2, 0 is the only x-intercept of f. Now we are required to calculate the coordinates of the turning points of f. That is question C. Now, to find the coordinates of the turning points, you find the second derivative. So remember, we have fx is equal to minus x to the power of 3 minus x squared plus x plus 10. So f prime x is equal to minus 3 x squared minus 2x plus 1. This is 0 at all the turning points. So we are saying minus 3x squared minus 2x plus 1 is equal to 0 at the turning points. Now, we can divide throughout by a negative. We got 3x squared plus 2x minus 1 is equal to 0. Now, allow me to use the quadratic formula. We're saying x is equal to minus b minus 2 plus or minus b squared, that's 4 minus 4. A is 3, c is minus 1. All over 2a, 2 times 3, 6. Then we have minus 2 plus or minus, what's in there? We got 4, then plus 12 over 6. So that's going to give us minus 2 plus or minus root 16 over 6. That giving us minus, that's, we get a 4 there. So minus 2 plus 4, we get a 2. 2 over 6. All minus 2 minus 4, we get a minus 6 divided by 6. We get a minus 1. So we are looking for the coordinates. We are looking for the coordinates, not only the values of x. So we need to take these back into the original equation there, this original equation. So we're going to look for f 2 over 6. I can just write f 1 over 3, just to break it down, is equal to minus 1 over 3 to the power of 3 minus 1 over 3 squared plus 1 over 3 plus 10. That's going to give us minus 1 over 27 minus 1 over 9 plus 1 over 3 plus 10. If I try to simplify this, I get a common denominator here is 27. I get a minus 1 minus 9 there, 3 there, 9 plus 9 plus, there's a 1 there, 270. That's going to give me minus 1 minus 3 is minus 4 plus 9. I get a 5. So that gives me 5 plus 270, 275 over 27. Point of correction. Earlier on, I meant to say to find the turning points, we must look for the first derivative, not the second derivative. Please forgive me. Anyway, let's continue. So we've got the corresponding value of 2 over 6 is this one. Now we're looking for the corresponding value of y for x is equal to minus 1. So we say f minus 1 is equal to minus, if I put it in the original equation, minus 1 to the power of 3 minus 1 squared minus 1 plus 10. That gives us a minus 1 and there a minus 1 minus 1 plus 10, and that is going to give us, okay, let me just check again. This is a positive there, okay? So minus times a minus that we're going to get there is a positive. So I'm going to have plus 1 minus 1 is 0, minus 1 plus 10, we get a 9. Now we have the corresponding value of 275 being 1 over 3. Okay, so now the turning points I'll write them as TPs, are 1 over 3, 275 over 27, and minus 1 and 9. Minus 1 and 9. That brings us to the end of that question. Now the next question requires us to sketch now the graph of f showing all intercepts with the axis of all turning points. Now I had prepared a grid here. I prepared a grid for that graph there. Now let's just put all the points there. I have the x-intercept. You remember earlier on we said the x-intercept is actually a 2. The graph is surely going to pass this 2. And the y-intercept in the first question was a 10. So it will pass there as well. Now I need to look at the turning points now. I got minus 1 and 9. Minus 1 and 9. So it's actually there. Minus 1 and 9. So I've got a point there. It's one of the turning points. And then I've got another one is 1 over 3. 1 over 3 is somewhere around here. If you look at this, we are sketching. Remember, we're not plotting, somewhere there. And 275 divided by 27, this is a bit more than 10. It's slightly more than 10. So it's just somewhere right here. So it's another turning point that we have here. Okay. Now, one thing to remember, if we have a cubic function, that is a x to the power 3 plus b x squared plus c x plus d. You look at the value of a to determine the shape of that curve. So if a is greater than 0, the graph starts with a positive gradient going up like that and that. If a is less than 0, the graph starts with a negative gradient and like that. So in this case, our a, if you remember from the question there, our a is negative there. So our graph assumes this shape here. So our graph is going to start somewhere from here, goes like that. It has to go a little bit up, but it's supposed to cut 10 there because that's the y-intercept. And then it peaks at the turning point before it returns to come here and cut the x-axis at x is equal to 2. So we must clearly indicate all the points. I've indicated the y-intercept. I've indicated the x-intercept. Now I also need to indicate the turning points. So I have 1 over 3, 275 over 27 here. And then I have a minus 1 and 9. That's the graph of a cubic function. Thank you so much for viewing. Don't forget to subscribe, like, share, and comment. Enjoy your day.